So we are recording now. All right. Okay. If I mispronounce your name in any way, please, by all means, correct me, and we'll find out who's here. Normally, Zoom does, indicate to me who has attended. So I may use that feature in the future. Sometimes weird handles are given for some students, in which case I have a hard time understanding who it belongs to. But I think what I might do is just also read off the names quickly during the session. So is Abigail Beckmeyer here?
Here.
Okay, thank you. Is Tyrone Bundy here?
Here.
Sean Carlite?
Here.
Carlisle, I do apologize. Amaya Clark.
Here.
Emma Clark.
Here.
Skylar Cup.
Here.
Giovanni DiMaggio. Giovanni.
Here. You can call me Gio.
Okay, Gio. All right. All right. How about Wade? Is it Gillian?
Yep, that's me.
All right. Caitlin Gilmore.
Here.
Jalen Hodges. Jalen. All right. Allison Jablonski, excuse me.
Here.
Okay. Let's see. It's Anastasia Colleen, correct? Anastasia. Delaney Kirk.
Here.
Carter Lakitz, is it? Carter. Joseph Laraldi.
Here.
Looks like Layla Lott. Are you here? Layla Lore. I do apologize.
Here.
Sorry about that. Caleb Matthews.
Here.
Sydney McLean.
Here.
Abigail Storms.
Here.
Okay. Dulce Varela. Dulce Varela. That name looks awfully familiar. Madison Thomas.
Here.
Julia Walton.
Here.
Nayla Zimmerman.
Here.
Okay. Anybody's name I did not call? Anybody's name? Okay, so far we're missing Hodges, Colleen, Lakitz, and Dulce Varela. That's it. Okay. All right, the syllabus here, ladies and gentlemen. My email address is right there, mark.austinware@mcc.edu. If you ever need to get in touch with me, that would be the way to do it. You can also leave a message with the secretary in the math office at the main campus. I do have a couple of classes on the main campus this term, so I will be checking my mailbox. So that's another way to get a hold of me, is leave a message with the secretary right there. All right, this class meets September 7th through the 21st of December. December 21st is our last day. All right, ladies and gentlemen, this course is on the STEM track here at Mott Community College. STEM, of course, stands for Science, Technology, Engineering, Mathematics. And it is designed to prepare you for future work in mathematics and also the computational sciences. All right. This course, does touch base with all the concepts that are covered in the first and second course in algebra. And you may have gotten in here by a placement exam. or bare minimum, they require that you have a 2.0 or higher in Math 120, which is intermediate algebra, or Math 118, which is a conglomerate of elementary and intermediate algebra. Or like I said, you may have been placed into this course here. All right, but the bottom line is, this being a college algebra class, this is not a first course in algebra. I mean, if you never had algebra before, you are so in the wrong place. Okay, this is not the course to be starting algebra with. This is, presupposing that we've had some elementary algebra in the past, and hopefully not too distant past. So that's kind of fresh in your mind still. All right. The textbook we'll be using is by Miller and Gherkin, and let me grab it here. It has like a tennis ball on the cover. And I don't know if anybody has this or not. Let's show you here. Okay, I don't know if you can see this. It's got like a tennis ball on the cover here. Okay. College algebra is the entitlement of it. Now there is an e-textbook that you're welcome to use on Alex, so you do not need the physical textbook. But we will need access to Alex, as that is an integral part of the course, as it will afford us homework problems and also quizzes that we will be responsible for. Okay. So again, you can use the e-textbook through Alex. You do not have to buy the hard copy textbook. It's up to you. So it's essentially your decision. Now, if you don't want to buy the hard copy textbook, when you register with Alex by clicking off to the side here on the Alex link, it's a one-time registration that you need to go through. You'll have to, you can purchase an online access code through the registration process. Or if you already have an access code purchased from the bookstore, you can use that in conjunction with my class code to register with Alex. All right. Okay. All right, a TI-84 calculator is required for the course. It is a graphing calculator. The TI-89 or TI-92 calculator is not permitted in the course. You can use an TI-83 or TI-84. They're essentially the same. Normally, it's the TI-84 nowadays. The TI-83 is kind of like a dinosaur. Believe you me, I still have one of those, but the TI-84 is what we're going to be using. And I do have an emulator right here, a TI-84 emulator. And so I will be, ladies and gentlemen, demonstrating many routines throughout the semester using this marvelous machine here, the TI-84. So try to bring it to every session, okay? All righty. Okay, obviously we need a secure internet connection to be successful in hooking up on a Monday and Wednesday at 2:30. Let's see, student code of conduct, a handbook, you should be familiar with that. Obviously, you want to drop into class on a regular basis on a Monday and Wednesday and come to class promptly, punctually. Taking thorough notes is something that is obviously very important to do. Ladies and gentlemen, there's an extra credit opportunity at the end of the semester. I'll have you email me a specific page of your lecture notes that you have been keeping throughout the entire semester. I'll indicate specifically when the time comes towards the end of the semester what I want you to email me. And if you can, email me what I request from your lecture notes, proving that you did take notes throughout the semester, I'll give you an extra 1% added onto your overall course average at the end of the semester after all the adjustments are made. So that's an excellent opportunity to boost your grade there. There is also another opportunity to boost your grade at the end of the semester. And this is the other opportunity on the main campus. Hold on, first of all, can we all see my doc cam here on the main campus? The Gorman room 2106. This is on the second floor of the Gorman building. There is going to be free tutoring available throughout the semester. And yours truly will be in this tutoring lab. I will indicate the schedule next week. It has not been nailed down yet, but I am told that next week we're going to fire it up. All right. It's a drop-in basis. You don't even need an appointment to come in here. You can just drop in and, work on your homework. We have ample seating, large tables. If you want to come in as a group and work on your homework or whatever. If you have questions, I'll be more than happy to answer those questions while you're in the lab there. You just need your student ID, you sign in, you can have a seat. There's also an island of computers where you can access the online too in the tutorial center. But here's another way to gain an extra 1% on top of the 1% if you forward the requested lecture notes at the end of the semester. I'll give you an extra 1% also added on to your overall course average. If you just keep track of the times and dates that you come into this lab. Normally you have like a piece of paper and you'll write the times down that you're in the lab, and I'll just sign it really quickly or initial it. Just keep that paper and you can email that to me at the end of the semester or give it to me in person, however, and I'll tack on an extra 1%. So there's a possibility that you can earn an extra 2% tacked on your overall course average at the end of the semester. Now that could be significant. Like if your course average is, let's say, like an 88%, and you get this extra 2% tacked on, it'll bump it up to a 90%. That could put you into a next higher grade category. Okay, so there's two ways to get extra credit. At the end of the semester, if you want to, you can submit to me what I request as far as proof of having taken notes throughout the semester. Number two, you can frequent the tutorial center here. On the main campus, the Gorman building, room 2106. You can earn a maximum of 2% to add on to your overall course average there. All right, does that make sense? Any questions about that? All right, and again, I will release that schedule and post it on Canvas as soon as I get that schedule. I know we're supposed to be up and running starting next week, this next week coming up here. Okay. All right, please leave your microphone muted, ladies and gentlemen, unless you intend to ask a question and or speak, especially like when you come into the class. If you attend class late, make sure your microphone's muted so that we do not disturb other students. That is just a common courtesy. And please do mute your microphone in general while in class because there could be background noise that could disturb other students there. By all means, you can ask questions at any time, but other than that, please have your microphone muted there. Whether you want your camera on or have your camera on, I'm going to leave that up to you. I'm not going to require that you have your camera on. Okay. All right. The only way to learn math, ladies and gentlemen, is not only by seeing some math done, but by immersing yourself in the math. Okay, spending time with it outside of class, and every one of us might have to spend a different amount of time on this subject to succeed at it. Some people not as much time, but other people maybe quite a bit more time. So you know who you are and how much time you're going to have to invest. So please do invest that time. And like I said, if you start slipping, there is tutorial help available. If you absolutely cannot make it to the tutorial lab, you can maybe set up a Zoom session with myself. I do tutor online for another company during the week and the weekend. So I'm really kind of busy with the classes and that, but I can probably still fit you in. All right. Okay, this is the grading scale that will be used for any graded work and also for giving you your final grade at the end of the semester. Normally, I also give you another benefit. If you're on the upper echelon of a grade category, unless you give me reason not to, I have no problem in bumping up to the next grade. For instance, if your overall average at the end of the semester, after all adjustments are made, is like 92% and maybe a little bit of change, a little bit of decimal after 92%, I will have no problem bumping you up to 4.0. Okay. All right. These are the graded vehicles for the course here, class activities, which will be performed during class. And obviously it requires attendance. It is weighted at 5%. Alex homework. And or any textbook homework. Normally the homework's just going to come from Alex. All right, it's weighted at 5%. However, ladies and gentlemen, I strongly recommend to be successful in this course that if you need extra practice, there's several extra practice problems at the end of each section that I cover in your textbook. And I'm even going to post the solutions to all your textbook homework problems for each section that I cover. I'll post all the complete solutions on Canvas. Okay, so that's a wealthy opportunity to strengthen your understanding. If you need extra practice, do some more problems in your textbook. And if you get stumped, the solutions are waiting for you on Canvas. Okay, but Alex is going to be the graded homework that is a requirement for the course. Quizzes will also be given on Alex. They're going to be weighted at 10% of your grade. Exams are going to be weighted at 60% of your grade, and those are also going to be given on Alex. So the exams will be on Alex also. Final exam, there will be a final exam, and it will be Alex, delivered by Alex, and it will be weighted at 20% of your grade. So essentially, we have to, somehow, some way get hooked up with Alex, because that really is, how you're going to get graded in the course for the most part. All right. If you don't show up after today, a no-show grade could be issued to you. Incomplete grades, I'm very reluctant to give incomplete grades, ladies and gentlemen, but there is criteria later on down in the syllabus as to how you would even qualify for an incomplete. History has shown that every time that I issued it incomplete, it's usually never followed up on, and I have to end up turning it into a failing grade. So I don't like giving incompletes out. This is extremely important. Any email you send to me, all that I ask, and this is very important, please try not to forget this, in the subject line of the email, please have these words, Math 130-hybrid 02, extremely important, because I'm bombarded with emails all the time, every day, ladies and gentlemen, and it's going to be difficult, okay, to sift through all these emails and to get to the messages for this course. Please do put this in your subject line every time you send me any sort of email. Very, very important. All right, this is the course code for Alex. You will need this in conjunction with your access code to register with Alex. It's a one-time deal registering with Alex. Once you register, you don't have to go through the registration ever again. You basically just click into it and get to work, okay? I'll try to show you something in Alex in a moment here. There will be 6 exams according to the schedule. Exams will be completed individually on Alex. Exams will be due midnight the day after they are made available, and that's subject to change. Please do check your email at least once a day, as often I do convey very important course information. So just get in the habit of checking your email. Late exams are penalized 10%. I will replace one lowest non-zero exam score with your highest exam score before computing final grades. There's going to be 7 Alex quizzes. They will be, again, due by midnight the day after they are made available, just like exams. Late quizzes penalized 10%. I'll replace one lowest non-zero quiz score with your highest quiz score. Okay. Homework is extremely important to succeed at a math course, so please do take homework seriously. There is no substitute for hard work and practice. I've seen hard work even supplant a weakness or a lack of skill in mathematics. Okay, hard work usually leads to good things always in mathematics. All right, homework is critical because it obviously gives you an idea as to where you are with the material. Are you getting it or are you not getting it? Okay, and I mean, if you're not getting the homework, ladies and gentlemen, then obviously you're going to suffer miserably on the quizzes and the exams. So it's really through the homework that we gain an understanding as to precisely where we are mentally with Math 130. All right. Exam questions are going to be similar to homework problems. So will quiz questions. That's why homework is so vital. I will post the, okay. Now, as far as this is concerned here, the homework will be on the, posted on Alex, okay? That's where the homework's going to be, and the due dates for the homework will be on the schedule that we'll look at in a moment here. All right. Now, because the homework is on Alex, ladies and gentlemen, it's not going to be emailed to me. I will basically be able to go to the grade center of Alex and just look that up. Okay, so just disregard all that. But the homework will be posted on Alex. Class activities are short written activities that are performed during class, and hopefully I'll have time to give you one today during lecture, and they will be due by midnight the same day. To receive credit for these activities, your attendance for the session is required. There is no makeups for class activities. So if you're not in attendance, you just miss it. I will drop, therefore, because of that, 2 lowest class activity grades before computing final grades. But again, there's no makeups on the class activities. You're either there to get it during our session or you just miss it. All right. And these activities obviously will address the problems that are being discussed that particular class session, and work must be shown. Now, I would like you to email me those class activities after class by midnight the same day that they were issued. And again, what are you going to put in your subject line so that I can locate them quickly? You're going to put what? Math 130 hybrid 02. Do you agree? Please put that in your subject line when you email me those class activities. All right. Final exam will be given on the last day of class. It will be on Alex. It'll be due by midnight, December 22nd. I got to have it because I have to have grades in by midnight, December 23rd. All right. If your final exam score is higher than the next lowest non-zero exam score, then I will replace the next lowest non-zero exam score with your final exam score. So, wow, that's quite an opportunity for success here, because I'm replacing one lowest non-zero exam score with your highest exam score. Then I'll replace the next lowest non-zero exam score with your final exam score, should it be higher. All right, please do check your grades frequently on Canvas. Let me know if there's any sort of error or discrepancy. I will investigate and make changes. Obviously, attendance will be taken every class, and I will probably, if I forget to read off the names during the session, I will check the Zoom report feature, to give me an idea as to what attendance I had. But I'm going to try to read them off, slip them in, and read them off every time also. Okay, and of course, being absent excessively could affect your financial aid if you are receiving that. All right, these are important dates here. September 12th is the last date to drop the course with a 100% refund. 50% refund can be obtained if you drop the course by September 16th. Last day to change the course to audit status, which I've never had to deal with, all right, in all my years, is November 4th. And audit status basically means you paid for the class and you basically just sit in and view the material for the course, but you don't actually receive a grade in the course, okay? Thanksgiving break is from November 24th to the 27th. The college is closed during that window there. Last day to drop the course is December 14th. So, like, if you're failing the course, if you're doing poor work in the course and failing, not going to make it, I would at least recommend that you view the course through the 14th of December to prepare yourself for taking the second time, when all the light bulbs usually come on the second time. But ladies and gentlemen, if you are failing the course and you do not formally withdraw from the course, you have to initiate the withdrawal. I do not do that. Then you could be issued a failing grade for the course, which would be, on your transcript, and that could hurt your cause if you transfer to some other institution. Okay, so just keep that in mind. If you have to bail out of the class, December 14th is the last day. Last day of class is the 21st of December, and I got to have grades in 2 days later. This is the COVID statement. Since this is not face to face, it's like, well, if you're not feeling good, you can still dial in, correct? It's not like you don't have to come to class. You could still, if you can sit up, or if you're coherent enough, you can still dial in for the lecture. So some of this does not pertain to us, but obviously if you come to the main campus, if you're not feeling ill, do not come to the main campus. If you want to come to like the tutorial center or something, please do not do that. If you've been exposed to COVID, here's the phone number for public safety to disclose that information. and to get further instructions as to what you should do. But again, a lot of these instructions pertain to if you're going to attend the main campus. All right. But being virtual here, you know, we're kind of off the hook for a lot of this stuff here. All right. So you're welcome to read this over. Title IX statement says that if you're pregnant and you have any, for an example, like if you are pregnant or something, if you have like any special needs, let me know about that. We also have a disability services. Here's the phone number. If you have any documented disability, secure the paperwork and forward it to me discreetly, ladies and gentlemen, and I will, by law, I have to honor any accommodation that the paperwork indicates. Okay, and I'll be more than happy to do that. All right, here's the criteria for being issued an incomplete grade. You can look at that, withdrawal policy, school closings. I don't think we'll have any school closings. You never know, but we shouldn't. Any questions here about the syllabus? All right, let's look at the schedule here. Okay. All right, this is the schedule that we will adhere to for the next 15 weeks. Today is the 7th day of September. I would like to try to get through section R2 and R3 if I can. And like I said, I will intersperse from time to time some very short class activities in here to try to see if you can basically emulate what I've been showing you. And those would be due by midnight tonight. So you can email me any class activities that I give you today by midnight tonight. Please, in the subject line, again, put Math 130 Hybrid 02 so that I know that, it pertains to this class. Notice that there will be an Alex quiz on Chapter R material. Chapter R is basically review. R stands for review, where we're going to kind of like review algebraic concepts to kind of get us up to speed for college algebra. All right. And there will be an Alex quiz, Chapter R quiz, that will be due October 3rd at midnight. I will open up that quiz when we get done with Chapter R here. So that quiz will be opened up on September 14th, and you'll have all the way to October 3rd by midnight to complete that quiz. All right. If you're late, of course, on that quiz, there is a 10% penalty. All right, your first exam on Alex on Chapter R and Chapter 1 will not be opened up until October 3rd. Let's see. Okay, there will be a quiz on Chapter 1, Alex quiz, that will be opened up on September 28th, and it will be due by October 3rd at midnight. And the exam, which, let's see, is slated to be opened up by October 3rd. I'll probably open up the exam on September 28th too, the quiz and the exam, ladies and gentlemen, and that will all be due by October 3rd midnight. Okay, both the quiz on Chapter 1 and the exam. I will open up again the exam on September 28th. Okay. All right, so basically this is how it's going to roll here. Any questions about the schedule here? Notice, ladies and gentlemen, on during the exam window, for instance, like on October 3rd, when the exam is going to be due by midnight for Chapter R and 1, I am more than happy to review any concepts from Chapter R and 1 or any questions that you may have. So notice I am not lecturing on that day, October 3rd. I'm just going to set that time aside for any questions that you may have. If you want me to work out problems in particular, I'll be more than happy to address the problems and demonstrate them. So that is basically your time, your day on October 3rd. And notice that'll be the case on every day when the exam is due by midnight of that day. Is that clear there as to what's going to go on here with the schedule? All right, so this is the schedule that we'll try to stick to, and hopefully things shall go okay. All right, now this Alex thing here. Ladies and gentlemen, when you click on Alex, this should take you right to Alex. Of course, if you're not registered with Alex, when you first click on this, it'll take you through a brief registration session, in which case you have to submit your access code and the course code to hook up with Alex. But after that, once you get hooked up with Alex, then you can just click on Alex and it should take you right to Alex. It'll probably open up in a different window on your computer, but it'll take you to Alex. And let me see if I can show you, here's a textbook right here. And if you click in the upper left corner up here, you can access the let's see here. Summary. Well, if you just click on the thumbnail of the textbook, it'll take you right to the textbook. That's a shortcut there. So this is your e-textbook here. And of course, this is the contents of the book. Okay, so it's all here. You got the entire textbook as an e-text. So you do not need the physical hard copy of the textbook. If you want to use it through Alex, by all means, go for it. No problem there. Okay. Now, this Alex thing is also going to have you go through an initial knowledge check. Okay. And it gives you like a horrendous number of problems, like 120 problems or some things like that. Ladies and gentlemen, the initial knowledge check is not a requirement for this course. You can skip the initial knowledge check. You can skip it altogether. And I'm just going to choose somebody here. And let's see if we can look at the student view here. So you don't have to go through this initial knowledge check here. You can just skip it. And initially, when you get into Alex, it'll start prompting you to go through and do the initial knowledge check. But eventually, you'll have a screen where down here it'll say like skip the knowledge check. Just click on it, and it'll skip out of that. The most important thing that we're going to be accessing is homework and quizzes. Okay, so you'll just click on in the upper left corner, click up here and click on assignments here. And notice the first assignment, homework R2, is open, and it's running from September 6th through October 3rd. And then you'll just click on this link and it'll take you right into the homework here. But again, this initial knowledge check is not required. You don't have to do it, right? You can if you want, but it's not required, right? And if you click on the homework, quizzes will also be listed too. You'll get a screen like this. And then you can start the homework assignment. The beautiful thing about the homework assignment is that you have unlimited takes on the homework, and I'll take the highest grade up to the due date. And and over here, let's see here. So, and you'll navigate through the problems up here on the top. And ladies and gentlemen, if you get stumped on a homework problem, you can click on off to the right where it says, show me an example. And, it'll walk through a similar problem. I mean, it'll show you all the gory details. Isn't that awesome? And then you can go back and, do your problem. Okay. So that's an invaluable tool, this example tool here. You can also tap into the e-textbook if you have to look anything up. You can, I think you can send me an email too, if you want to. You can look at a guided solution. So you can actually have the computer walk you through your problem interactively, all right? So it's a really nice environment. But notice, I think what it does is when you go through a guided, when you have the computer guide you through the problem, I think it marks the problem wrong. Do take that into account. Heck, you know what? I would just click on the example and just view a free example, a similar problem, and just kind of look and see how they're doing that problem. And then you can go back and do your problem. That's what I would do. All right. So again, the initial knowledge check is not required for Alex. You don't have to waste your time with it. You just have to basically just skip that and then have access to the textbook, I mean, the homework assignments and the quizzes. That's it. And of course, the exams will also be listed when they are opened up. So is that clear about what's expected from Alex? Again, don't do the initial knowledge check. All right.
Yep.
Okay, ladies and gentlemen, if there are no other questions, then I think we can maybe get started here. This session is being recorded. I will try to make it available, barring no technical difficulties. That's always an issue, never fails. But generally speaking, things usually go pretty smoothly. At least they did the last semester. We'll have to, test the waters this semester and see how it goes. But if there are no other questions, I guess we can get started. Again, just please be in the habit of checking your email frequently, as I do often convey important information. And I will be posting more links on the main dashboard as the semester, wanes. Other links, I might even put video links of important videos that I dredge up that I feel are necessary or important. I'm going to put a link on here for the solutions to all of your problems at the end of your sections in your textbook. If you want extra practice, definitely try to do some of the problems in your textbook. And if you get snagged, no problem, because I'm going to give you all the solutions to those. They'll have the detailed steps. Okay, I will post that link. Another thing, ladies and gentlemen, that is not required, but I strongly recommend it, is every section that I go over in class, I would strongly recommend that outside of class, you bare minimum at least look at the examples in those sections. Look at the steps your author is going through to get the solution to those problems. I think by looking at the examples in the sections that I cover, coupled with my lecture material, I think that's going to enhance your understanding of the course big time. Okay. Again, that is not required, but I would strongly recommend that you look over the sections that I cover during class. Look over those outside of class look at examples. And if you ever have any questions with any examples or any questions with any problems out of the textbook that you're stumped on, I'll be more than happy to, field any of those questions. Normally, I like to have those questions posed to me towards the end of the session because we do have a regiment that we have to get through, but I'll be more than happy to field any questions if you have any. If you want to come to the tutorial center, ladies and gentlemen, and hang out with me and bug me as much as I should be bugged, I'll be more than happy to help you out with any questions you have. Okay, so always keep that in mind. Again, the tutorial center is in the Gorman building, which is the math science building on the main campus on the second floor, room 2106. I will get the schedule to you as soon as I learn of it. I will also post a link on Canvas that will have the times and the days of operation. All right, does anybody have any questions? Any questions or comments here? All right, well, if not, I guess we can get going on this. So what I'm going to do is click off of the screen share and enable my doc cam here. Let me see something here. Yeah, okay, so we can all see my doc cam here. Okay, I will be demonstrating problems on my tablet here. All right. And by all means, if you have any questions or you're confused about anything, stop me and I'll be more than happy to try to clarify things for you. All right, so ladies and gentlemen, we are going to begin. I'm going to try to get through sections R2 and R3 today, okay? All right, so section R2 is going to have us review what are called integer exponents. And there are quite a few properties of exponents. Like I said, I mean, most of this should be reviewed in all honesty. I mean, if you've never seen any of these properties before, never worked with exponents before, college algebra is not the course to be starting off with. Okay, you should be starting off with elementary algebra. All right, let's look at some properties of exponents. Never hurts to review in mathematics. All right. Math is a type of thing where you really should review on a continual basis. It's so easy to get rusty with mathematics if you shove it aside. All right. First of all, ladies and gentlemen, if you raise any quantity to the 0th power, by definition, it's always equal to 1, provided that that quantity is not equal to 0. In other words, 0 to the 0th power is called an indeterminate form in mathematics and has no meaning. All right. But anything else raised to the 0th power is 1. Does anybody remember what we do with exponents when we multiply like bases together? We keep the base the same, and what do we do with the exponents?
You add it.
We're going to add our exponents together, correct? That is the property that we learned a ways back. All right, what happens when we raise a power to a power? If I have
You
like b to the nth power to the
multiply the exponents.
then we keep the base the same, and yes, we are going to multiply the exponents, okay? So when you raise a power to power, you multiply the exponents. When we divide like bases, what do we do with the exponents?
You subtract them.
Okay, we are going to keep the base the same and subtract them. And notice my order of subtraction. I took the numerator power and subtracted off the denominator power because I left the base in the numerator. You see that there? This is understood to be over 1. All right, all of these are valid properties of exponents so far. Any questions so far? All right, if I have like a monomial, like AB raised to the mth power, then that's saying that every factor of the monomial deserves to get raised to the what? The mth power. Do you agree? This is a valid property of exponents there? All right, and that's also true if you have like a quotient raised to a power, like a divided by b to the mth power. I can rewrite this as a to the mth power divided by b to the mth power. And since we're dividing, we got to make sure that we never perform a division by 0. Agree? Because dividing by 0 is an undefined operation in mathematics. Any questions about any of these rules of exponents so far, ladies and gentlemen? All right. Hopefully these look familiar to you. The definition of negative exponent now is this. If I have a base raised to a negative exponent, in order to do away with the negative sign on the exponent, we're going to have to reciprocate the base. In other words, we have to flip it. So if this base b is in the numerator raised to a negative exponent, we have to flip it down into the denominator, in which case we call this equivalent to 1 over b to the positive nth power. Or if I have a negative exponent appearing in my denominator, I would have to flip my base up into the numerator to do away with the negative exponent. Okay, so both of these are illustrating the definition of negative exponent. So negative exponent suggests we take reciprocal. We flip the base upside down. Okay. All right. Any questions about any of these properties of exponents so far here? All right. This is an extension of the definition of negative exponent. If I have like a fraction raised to a negative exponent, how would I get rid of the negative sign on my exponent? I would just do what to the fraction? Just flip it upside down. Do you agree? Take the reciprocal of it. So this would be equal to b over a now to the positive nth power. That makes sense, sir? Are these properties making sense, ladies and gentlemen? Have we seen these properties before? Okay.
Yes.
Just let me know. Let me know if there's any questions ever. Okay. All righty. Do we have this accounted for, this sheet here? Again, this is being recorded, so I should be able to get this to you also. All right. Well, let's start looking at a couple of examples now. The only way you learn math is by looking at a lot of problems. Okay, that's how you become experienced. There is no substitute for experience, and how you gain experience is by spending time with math. All right. All right, so if I have this expression here, I want to simplify this expression. Normally, we don't like to leave negative exponents appearing in final answers, unless, of course, we're working with what's called scientific notation. Then it's different, okay? But all of this sits over what? What can I put this whole quantity over? No harm done.
1.
Over 1. Now, I want to get rid of my negative exponent of -2 here, so that I have to flip what? What has to be brought down into the denominator?
The x.
Just the x. Notice it's only the x to the -2 power, so I'll have 8 over x to the positive 2 power, and that's called simplified, correct? That one's good. Now, I want you to contrast that problem with this one here. If I have 8x inside the parentheses raised to the -2 power, okay, now notice now it's saying that 8x is to the -2 power. Okay, not just the x like over here. So now to do away with this negative sign on the exponent, I would have to flip the whole base 8x down into the denominator. So this would be equivalent to 1 over 8x squared, and which is really equal to 1 over 8 squared x squared, correct? Right, hold on a second. Right, like that, which is really equal to 1 over 64x squared. Any questions how we simplified this from here down to there? All righty. Any questions about that? All right, if I have -7 to the -2 power, what's this going to simplify to? All this sits over 1, so I would have to flip the base down into the denominator and say this is equivalent to 1 over -7 to the +2 power. And this is really 1 over -7 times -7, which is 1 over 49. And that would be your simplified result, right? All right. As opposed to if I have the opposite of 7 to the -2 power, this is saying something different. This is saying the opposite of 7 to the -2 power. So the only thing that gets flipped down to the denominator is just a 7. So we're still going to have the negative sign outside of this fraction here. So we got 1 over 7 squared, which is going to be -1 over 49. So you just got to be careful with some of your details in math. I mean, it looks like these are saying the same thing, but they are not saying the same thing. Okay. We all good on that so far? These simple examples?
Yep.
Okay, working with some integer exponents. All right, let's try this one here. Obviously, those are kind of simple. They're not always going to be that, you know, that simple here. Here's one that has a little bit more going on with it. You know, but some problems in math, they're just a lot longer. They just require a little bit more patience and time to get to the solution. And please do exercise that patience and time, and please get in the habit of laying your steps out on your paper, as that's a very important habit to adopt, not only for this course, but for any computational course. Reason being is because when you show your steps, it helps keep you out of trouble with silly mistakes. And also it's easier to troubleshoot your problem if an error does occur. All right, there's a lot going on with this problem. I see negative exponents everywhere, so something's got to be done with this thing. But the big question with this problem is where to begin, because it seems overwhelming. There's a lot going on here. And usually in math, there's more than one way to do a problem. You know, I don't really care what way you go about doing this problem. I just hope you choose a way, and your way is a valid way according to the rules of exponents. That is what is important. Okay, so we are going to try to simplify this expression here. And, you know, from the order of operations, we are kind of taught always to kind of like go inside parentheses first and then entertain any expressions therein. So I'm going to go inside these parentheses here, and then I see this big old, you know, quotient expression here, and I see a whole bunch of negative exponents here. Upon further inspection, I see that I have x to the -3 power raised to the -4 power. And when I raise a power to a power, what am I to do with these exponents when I raise a power to a power?
Multiply.
So I should multiply these exponents, correct? So I'm going to take care of that business first here. All right, so that's the first thing I'm going to do. So x to the -3 power raised to the -4 power is going to be x to the -3 times -4 power, or x to the 12th power. And that's going to be multiplied by this x to the -2 out here. And this is going to be divided by x to the -6. And then this whole quantity is going to be raised to the -1 power. All right, I'm still inside the parentheses here. And I'm still going to work inside the parentheses, specifically with the numerator here, x to the 12th power multiplied by x to the -2 power. When I multiply like bases, I keep the base the same and I add the exponents. So x to the 12th times x to the -2 power is going to be x to the 12 plus -2 power, or x to the 10th power. And that's going to sit over x to the -6. And all this is to be raised to the -1 power. So we are getting there step by step. We're still inside the parentheses. Now I'm going to have to address the fact that we're going to have to what? Divide these like bases. And to divide like bases, we keep the base the same and we subtract the exponents. Specifically, I'm going to take the numerator and subtract off the denominator exponent. So this will be 10 minus -6. And then this whole thing is going to be raised to the -1 power. Now, what is 10 subtract a negative 6? What's that going to give me?
You're gonna add 6.
Yeah, that's going to be 10 plus 6, which is going to be 16, correct? All right. So therefore, we're going to have x to the 16th power, and then this whole thing must be raised to the negative 1 power. See, we got it all the way down to this now, and we're almost done. One last step now is to address the outermost exponent. Specifically, how do we raise a power to a power? We are to multiply these exponents, and so we'll have x to the negative 16th power. Finally, to wrap this problem up, we just reciprocate the x downstairs, and then we have 1 over x to the 16th power, and that's your final answer to what really looked like a very complicated expression. Do you agree? We got it down to 1 over x to the 16th. Any questions about that problem, ladies and gentlemen? That's just a lengthy problem, isn't it? Let's take some time to get down to where we need to get. But the key is, this illustrates the patience we should have. Try not to do everything all at once up here. It will lead to error, never fails, okay? We got to fight the urge to try not to do everything all at once, because it gets all tangled up and errors seep into the problem very quickly. So we just have to have a little bit of patience. Now, don't get me wrong. There might be some subtle steps that you might want to, sidestep. And I don't mind if you take some shortcuts, that's okay. But when you start taking big shortcuts and trying to muscle this out all on one line here, be on guard, because usually your result will be in error, okay? All right, any questions on that there? Working with integer exponents here. And obviously you have to know the properties of exponents. So that's why it's important to maybe I would recommend just memorizing these properties here. Okay, I know it seems like a lot, but these properties are critical, not only for this course, but you go onwards and you take like some pre-calculus or get into your calculus sequence and differential equations and beyond. Ladies and gentlemen, rules of exponents are always going to be a part of the game. Okay, so it's very important to get familiar with those rules of exponents here. All right, shall we maybe try one more here, and then I'll give you like a classwork here. And all right, this is a big old problem here. We got 4v w to the negative 1 power x squared, and the whole thing is squared. And this is all going to sit over 2v squared w cubed x to the negative 2 all raised to the 4th power times negative v cubed w squared x to the negative 4th power all raised to the negative 5 power. We're going to try to simplify this big old nasty expression, and of course this sits over 1 understood. Okay. All right, there's a lot going on here, and there's a lot of room for error. Okay, so we just have to have patience and just chip away at it one little thing at a time. Okay, let's just analyze what we got going on here. I see a lot of expressions raised to powers. Okay, this expression to that power, this expression to that power, this expression to this power. I don't see any like bases that need to be multiplied together inside the parentheses here or here or here. That being the case, I would probably be tempted to address the outermost exponent here first. So everything inside the parentheses here has to be raised to the 2nd power. The 4, the v, the w, and the x have to be raised to the 2nd power out here. So I'm going to address that first. Here we go. So 4 squared times v to the 1st power squared, which is really just v squared, times w to the negative 1 power, which must be squared, times x squared, which must be squared. Everybody see that there? Downstairs, everything inside the parentheses here must be raised to the 4th power. So therefore 2 must be raised to the 4th power. V to the 2nd must be raised to the 4th power. W cubed must be raised to the 4th power. X to the negative 2 power must be raised to the 4th power. All right, times everything inside parentheses here must be raised to the negative 5 power. I have a question. What would be the coefficient in front of all these variables here? I just see a negative sign. What is it understood to be the coefficient here?
-1.
-1. Understood to be like -1. Okay, so let's treat it like that. So therefore, this -1 must be raised to the -5 power. V cubed must be raised to the -5 power. W squared must be raised to the -5 power. And this x to the -4th must be raised to the -5 power. All right, and all this is understood to be sitting over 1, okay? All right, so we just addressed the outermost exponents first here, and now we can go through and start cleaning this up. 4 squared is 16. V squared, when you raise powers to powers, you multiply the exponents. So w to the -1, the second power is w to the -2 power. X squared squared is x to the 4th. And this sits over 2 to the 4th power is 16. V squared to the 4th is v to the 2 times 4, or v to the 8th. W cubed to the 4th is w to the 3 times 4, or w to the 12th. X to the -2 to the 4th is x to the -2 times 4, x to the -8th. And it's going to be times, now -1 to the -5 power would really have me bringing the -1 down into the denominator down here technically. So I'd have -1 to the +5 power, okay? And v to the 3rd power to the -5 power is going to be v to the -15th power. W squared to the -5 is going to be w to the -10 power. And x to the -4th to the -5th power is x to the +20th power as we multiply these exponents together. All right, so we got it down to this. Hey, these 16s reduce, don't they? Let's just reduce these 16s out. They're gone. And, you know, we could do a couple things here. We could start dividing like bases, or we could multiply this by this first and then start dividing like bases. I mean, that's entirely up to you here. What I'm probably going to do is I'm going to put this together with this and multiply like bases together. So I reduced to 16s. Now this v squared here, this v squared, I can multiply the v squared by v to the -15th power. And when we multiply like bases together, we add the exponents. So v squared times v to the -15th is going to be v to the what? What's 2 plus a -15?
-13.
So I'm going to say v to the -13th power times now w to the -2 power multiplied by w to the -10th power. As these are like bases, they need to be multiplied together. Will give me w to the -2 plus -10, or w to the -12th power. Finally, I have x to the 4th times x to the 20th power. So we basically link up our x's here. X to the 4th times x to the 20th is going to be x to the 24th power. And this is all going to sit over. Now, what's -1 raised to an odd power? -1 to an odd power is what? Always going to be -1, correct? So the way it works is -1 to an odd power is going to be a -1. -1 to an even power is going to be always a what? A +1, correct? Isn't that how it works? All right, so we know this is going to be a -1. Now, you can just, you know, put this -1 in the denominator here. You just put the negative sign down here, or the -1. And then we got our v to the 8th here, w to the 12th, and x to the -8th down here. That's what we got downstairs. All right, the only thing that remains now is dividing like bases. By the way, this negative sign in the denominator here, you can even bring the negative sign, you could attach it to the numerator or even bring it outside your fraction. All right, so I'm just going to put it outside my fraction. Now I'm going to divide my like bases of v. What's v to the -13th divided by v to the 8th power? When we divide like bases, we subtract exponents. So this is going to be v to the -13th subtract 8 power. Times w to the -12th divided by w to the 12th power is going to be w to the -12 power minus 12. X to the 24th divided by x to the -8th power is x to the 24 subtract a -8. Just got to be careful with all these signs, of course. All right, and so therefore we're going to have negative v to the, what's -13 minus 8? 8. I think that's -21, correct? Negative 12 minus 12 is negative 24. And 24 subtract a negative 8 is 24 plus 8, which is 32. All right, one last thing now is to get rid of our negative exponents. And so we will have a negative x to the 32nd power will remain in the numerator. Coming downstairs is going to be the v to the what? 21st power and the w to the 24th power. And ladies and gentlemen, we are done. We've gotten that nasty big old expression all the way down to this. That makes sense there? It's just a lengthy problem is what it is. I mean, you just have to exercise, patience and perseverance here. And, you will eventually get down to your answer if you're obviously using valid properties of exponents. All right, that's the key. Is whatever move you make, it has to be a valid move. And it has to be the use of one of these valid properties of exponents. As soon as you start deviating from these valid properties, then you're doing something else. Okay. All right, any questions? That was a nasty problem, wasn't it? That was a long one there. All right, classwork number 1, ladies and gentlemen, I'm going to give you just a couple of problems to play around with. I don't think they're going to be as involved as that last one, but I just wanted to stretch our minds a little bit. There's nothing wrong in doing that with mathematics. The nice thing about doing very difficult problems in preparing for like an exam or a quiz is that if you can do a difficult problem, then all the other problems are going to seem trivial. You agree? That's a great way to prepare for an exam in math, is to run your mind through, basically put your mind through hell. Drag it through the mud by doing very difficult problems, because when the exam comes before your eyes, the exam is going to seem easy. All right. But if you prepare for an exam by doing simple problems like 1 + 1, then when the exam, comes before you, then the problems are going to probably seem very difficult. So a good way to prepare for a math exam, do difficult problems. Okay. Stretch your mind big time. And that way the exam will seem easy. All right. All right. Classwork number 1 today, at the top of your paper, just put your name and classwork 1. Today's date is September 7th. That'd be great also. I want you to simplify this expression here, utilizing properties of exponents. So this will be problem number 1, 2m to the negative 6 times n to the 4th power divided by 6 m to the negative 2 n to the negative 1 power. See if you can simplify that expression using valid properties of exponents. And one more problem here. See if you can then simplify this one. Negative 2y to the negative 3 power. I want you to multiply that by 6y to the negative 2, z to the 8th raised to the 2nd power. So I've given you 2 problems. I'll give you some time to work on that. Go ahead and do that, and then we'll take a look at these. Okay, so that is the result for number 1 there. Let's take a look at number 2. Number 2, the first thing I did was address this outermost exponent of 2 in the second parenthesized quantity here. And so I incorporated that 2 into each of those factors as an exponent. And then I went further to simplify all of these down to this. And then what I did is I multiplied like bases together. Negative 2 times 36. And I actually brought the bases adjacent to each other, rearranged them so they're adjacent. You don't have to do this. You can use like connecting bars if you want to. That would be okay. But I decided to put them adjacent to each other here. And then we multiply everything out here and get rid of your negative exponent in the end. And I do get this here. Did anybody get that? That problem?
Yeah.
Okay. All right, so hopefully, ladies and gentlemen, this seems like somewhat familiar, working with integer exponents, and hopefully you got maybe at least one of those correct. If you made a mistake, it's always wise to go back through and troubleshoot your problem. That's why it's extremely important to lay your steps out, because otherwise you're not going to know where the mistake occurred. Okay, so please do get in the habit of doing that. Now, I know the quizzes and homework are like on Alex, and it's not like I can, come to your house and make sure you're showing your work and your steps and all that. But trust you me, if you have to take more math, ladies and gentlemen, above and beyond college algebra here, you had better get used to showing your steps, because when we get back face to face, your instructors are going to demand that you show steps. All right. So don't fool yourself, and don't cheat yourself. Make sure you're showing steps. Okay. All right. The only other concept in this section here is just to touch base briefly with scientific notation. Obviously, this is important if you get into any of the sciences. Scientific notation is a very compact way of representing very large or very small numbers. In general, scientific notation has a very rigid format, where this A here is an integer that is either equal to a 1, a 2, a 3, a 4, 5, 6, 7, 8, or 9. Okay. And the decimal point is here. So to the left of the decimal point has to be an integer that's either 1, 2, 3, 4, 5, 6, 7, 8, or 9. You can have positive or negative scientific notation numbers, and the exponent indicates which way you move the decimal point. If you have a positive exponent, you move the decimal point to the right to go to decimal notation. If you have a negative exponent, you move your decimal point to the left. All right. Let's try out a couple here. I'm going to give you a number in decimal format, and you tell me, is this a large or a small number? Is that a big or small number?
Small.
Okay, this is a very small number because one whole is way up here, correct? This is an extremely small number, and to put it in the scientific notation form, we would have to move our decimal point to such a place whereby to the left we have an integer that is to the left of the decimal point, and the integer has to be in this list. So the only place that decimal point can go is between the 3 and the 5. To get it there, we have to move it 1, 2, 3, 4, 5, 6, 7 places. So in scientific notation form, this number is 3.5 times 10 to the negative 7th power. Okay, and that's a very small number. All right, that's what that number would be. As opposed to that small number, when you start looking at bodies in the universe, distant stars or planets, ladies and gentlemen, you're starting to talk about the other end of the scale. You're talking about very large numbers, okay? And this is a humongous number. Notice the ones position is right here, the decimal point's right here. So to put this very large number in the scientific notation form, I would have to move my decimal point between the 1 and the 4, because remember, to the left of the decimal point has to be an integer. So this would be equal to 1.49 times 10. This is times, this means times, not the x variable. This means times 10 to a power, times 10. How many places to get it there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is to the 12th power. And that's what that number would be in scientific notation form. That's a very big number, correct? So small numbers have negative exponents, big numbers have positive exponents. And keep in mind, ladies and gentlemen, that if I preceded these numbers with like a negative sign, you just put the negative sign in front, correct? Like if this was a negative, that would be a negative there. Does that make sense there? Scientific notation form. You will see that notation used a lot in the sciences. You know, that COVID virus is so small that you'd have to use a scientific notation number to represent its diameter, okay? And then you got very large things like the diameter of the sun is humongous. And the sun is very large and could swallow up thousands of our planet Earths. That's how big the sun is, all right? Okay. Well, working with scientific notation a little bit, if I give you 6.2 times 10 to the 11th power, and I want you to maybe multiply this by 3 times 10 to the 4th power. How would we do that? Well, you might want to multiply the 6.2 by the 3 first. And so we'll multiply the 6 and 2/10 by 3 times, and we're going to multiply our like bases of 10 together. 10 to the 11th times 10 to the 4th power. All right, now 6.2 times 3 is 18.6. And times 10 to the 11th times 10 to the 4th, we add the exponents when we multiply like bases, so this is 10 to the 15th power. Now this is not in scientific notation form, as we have a number to the left of the decimal point that's not in our list of 1 to 9. So we're gonna have to move our decimal point one place to the left to force this to be in scientific notation form. But I have a saying, ladies and gentlemen, to remember this. If you move your decimal point to the left, we heft. To the left, we heft. Now, what does that mean? Well, it's an easy saying that rhymes and sticks in your mind. To the left, we heft. That means if I move my decimal point one place to the left, I'm going to have to heft up my exponent by 1. So this is going to be 1.86 now times 10 to the 15 plus 1 power, or 1.86 times 10 to the 16th power. Okay, so when we move our decimal point to the left, we heft our decimal point up. We build it up. Okay, so we have this right now, 1.86 times 10 to the 16th. As opposed to if I had this right here, if I had this number right here, now I would have to move my decimal point to the right to force this to be in the scientific notation form. In fact, I would have to move it 2 places to the right. And I have a saying for that. If we move our decimal point to the right, we slight. Okay, to the right, we slight. To slight the exponent means to subtract off from the exponent. To heft the exponent means we add on to the exponent. So in scientific notation form, this is 1.5 times 10 to the, I moved my decimal point 2 places to the right, so we slight our exponent by 2. So 4 minus 2 brings us down to 2. And now that's in scientific notation form. All right. So the left we heft, the right we slight, if you have to make any final adjustments in putting a number in scientific notation format there. That makes sense there? Working a little bit with scientific notation. All right. Okay, we have to wrap this section up because the clock is our enemy right now, ladies and gentlemen, and we are losing the battle. So we move on. All right, the last section is R3. It addresses what are called rational exponents. Rational exponents, and we're going to find out that rational exponents are really also equal to radicals in mathematics. Radicals are roots, like square roots, cubed roots, fourth roots, etc., etc. Okay. So I'm just going to give us a definition here to get us started. For an integer n greater than 1, so that would be like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, some sort of an integer greater than 1. If you take the nth root of b, wait a minute here. And ladies and gentlemen, if it is true that the nth root of b, the nth root of a rather, excuse me, is equal to some number b, then this would imply that b to the nth power is equal to a. All right. And this is accurate to say as long as a is non-negative and b is non-negative. All right. A is greater than or equal to 0, b is greater than or equal to 0 there. All right. So like if I take the cubed root of 8, that's how we read that notation, the cubed root of 8. After a little thought, we can realize that 8 really is what? Perfect cube to what whole number? Of
2.
2. So the cubed root of 8 would be equal to 2. Why? Because 2 raised to the third power gives us back 8. Is that correct? All right. So specifically, we are discovering very quickly that when you take an nth root of a to the nth power, that's basically going to give you a back. All right. So notice that taking the nth root and raising a quantity to the nth power are inverse operations of each other. They undo each other and give you back basically just a base here. All right. So like if you take the square root of 4, 4 being what? 2 squared. So the square root of 4, which is the square root of 2 squared, is just going to give you 2. The square root of 16, which is the square root of 4 squared, is just going to give you 4. You take the cubed root of 27, 27 being what? 3 cubed. So the cubed root of 27, which is the cubed root of 3, is just going to simplify down to just 3. All right. If you take the fourth root of 16, where 16 is really 2 to the 4th power, that's going to simplify down to just 2. Is this making sense here? Hopefully you've worked with basic roots in the past, correct?
Yes.
All right. All right. Working with radicals. These are all called radicals, or they belong to the family of roots. All right. But there's an even more remarkable result involving radicals that we're now going to investigate here. All right. If I'm ever going a little too fast, you can try to slow me down, ladies and gentlemen. I cannot guarantee that I'm going to slow down, but I will try. Okay. Yeah, we are viciously trying to fight the clock today because I had to go over the syllabus, and the syllabus burned a lot of valuable time. That's why first days are always a hassle. Okay. All right, but the pace will slow down a little bit after today. Don't think the pace is always going to be this feverish. Okay. All right. Another thing, this is very important. If I take the square root of like -25, does anybody know what that would simplify or evaluate to? The square root of -25.
Wouldn't it be 5i?
Yeah, actually, ladies and gentlemen, this is a non-real number. Do you agree? It's not a real number anymore. It's called an imaginary number, and you are correct. I mean, it would be 5i, which is called a pure imaginary number. But if you don't remember that, don't worry about that. We'll be getting into those. But the bottom line is when you take an even root of a negative number, it's always going to be a non-real result. Okay, this is true if n is even. So if you try to take like a square root or a 4th root or a 6th root or an 8th root of a negative number, it's always going to be a non-real number. However, if you take like an odd root, like a cubed root of a negative number, now it will be a defined real number because the cubed root of -27 is really the cubed root of -3 cubed, which gives you -3. So you can take an odd root of a negative number and get a real number, but you cannot take an even root of a negative number and get a real number. All right. So I wanted to point that out there. All right, now definition of rational exponent. Yes, there do exist fractional exponents. And there's a lot of mathematical formulas used in the real world that actually involve the use of rational exponents. So basically, this rule says this: when you have a raised to the m divided by n power, you have base a raised to a fractional exponent, a rational exponent. You can really rewrite this as an equivalent radical expression. You can rewrite this as the nth root of a to the mth power. Or you could even bring that mth power outside of the radical. You could say this is the nth root of a, all raised to the mth power. These are all equivalent to each other, okay? So when you raise a base to a rational or fractional exponent, it's really like taking a root of that base raised to a power. Notice in particular, the denominator becomes the index on the radical. It qualifies it as to what kind of root it is. The numerator becomes the power on the base. All right. That is the definition in a nutshell for rational exponents. So to put that into practice, if I have 81 raised to the -3/4 power, how would this simplify? Well, first of all, we can put this whole expression over 1, correct? Now, to do away with a negative sign on the exponent, we evoke the definition of negative exponent. So I can rewrite this as 1 over 81 to the +3/4 power. But ladies and gentlemen, 81 to the 3/4 power really suggests that we are taking a root of 81. Specifically, we are taking the what root? I'm going to be taking the what? The 4th root, correct? The 4th root of 81 raised to the 3rd power. That's what this is equivalent to. Now, I don't want to take 81 and cube it, so I'm going to bring the cube outside because my life's going to be easier if I do that. So I'm going to rewrite this as 1 over the 4th root of 81, and then I'm going to cube that end result. The reason why I did this is because I know that 81 is really what whole number to the 4th power?
3.
3. 81 is 3 to the 4th power, so the 4th root of 81 is really 3. Hence, we have 1 over 3 cubed. And 3 times 3 times 3 is 27. So the end result is 1 over 27, and we're done with that problem. Okay, we have simplified 81 to the -3/4 power. It's equivalent to 1 over 27 there. And you know, you could check this result using your calculator too. Do you agree? If you raise 81 to the negative 3/4 power, it should report 1/27. Let's see if I can show you that real quickly here. Bringing up the old machine. Okay, so I'm going to raise 81, raise it to the negative 3/4 power. I'm going to include the negative exponent inside parentheses. So negative 3 divided by 4, closed parenthesis, hit enter, and you get a decimal. I'm going to hit my math button now, ladies and gentlemen, math button, and go down and select my frac function. Math fraction will turn this decimal into a fraction, and I get indeed 1/27. Everybody see
Oh,
do we see that? Is that pretty cool or what? All right, 81 to the negative 3/4 power is 1/27. All right. So, you know, you can use your calculator, you know, to check answers. In fact, I encourage you to do that. Although, you know, it would be also nice to be able to, you know, come up with a solution in a manual sense too. It would be nice to have a happy marriage between the manual way and the calculator way of demonstrating an answer. Okay. And we'll be going through quite a few routines on the calculator anyways to help us deal with more elaborate situations in the future here. Ladies and gentlemen, all the properties of integer exponents carry right over to rational exponents. So rational exponents obey every property that I've shown you for integer exponents, all right? There's no difference. The properties are still in effect. So if I got like 5c to the 3/4 power to the second power, and this is all divided by 2c to the 1/2 power, how would we simplify this expression here? Well, we can use all the properties of integer exponents also for rational exponents. All those properties that we've seen in the past, we can incorporate those into this problem here too. So first I could deal with the outermost exponent. I would have 5 that has to be squared times c to the 3/4 that has to be raised to the second power. And all this is divided by 2 times c to the 1/2 power. Now 5 squared is 5 times 5 or 25. And c to the 3/4 raised to the second power. When you raise a power to a power, you multiply these exponents. This 2 sits over 1. So what's 3/4 times 2/1? Well, that gives me 6/4, which reduces down to what? 3/2. So I really have c to the 3/2 power. And this is to be divided by 2 times c to the 1/2 power. Unfortunately, 25 cannot be divided by 2. And when we divide like bases, what do we do with the exponents? We are to subtract the exponents. So it's going to be c to the 3/2 minus 1/2 power. Final answer looks like it's going to be 25/2 times c to the 2/2 power. But another name for 2/2 is what? 1, correct? So this is really going to be 25/2 c. Or you could express it as 25c over 2, same thing. We all understand, ladies and gentlemen, how integer exponent rules carry right over to rational exponents? Nothing changes with the rules, okay? The only difference is you're working with fractions instead of integers, but the rules remain the same for exponents. All right. Okay, how about those radicals? Now let's get back to the radical world. Ladies and gentlemen, hopefully you've had a chance to touch base with working with radicals. Oh, I know they're not a favorite among students, but they do surface in the real world and application problems. The nth root of a product, I don't know if you're aware of this or not, can be rewritten as the product of nth roots. This is called the product rule that all radicals obey, the product rule. So the nth root of a product can be rewritten as the product of nth roots. There's also a quotient rule that radicals obey. The nth root of a divided by b can be rewritten as the nth root of a divided by the nth root of b. Of course, b cannot be equal to 0. This is called the quotient rule. Do these rules look familiar? Have you seen those before somewhere?
Yeah.
Okay. Moving onwards. All right. You know, the beauty of this virtual delivery is you get your lectures kind of like recorded, which I will try like heck to make them available. What a luxury that is, big time. All right, ladies, when working with roots, there's three bases that we need to make sure are covered before we call our final answer simplified, okay? Number one, you never want to leave anything to the nth power underneath an nth root. This is not considered to be simplified, okay? Number two, you never want to leave a fraction appearing underneath a radical. This is not considered to be simplified. These are not my rules. These are general customs of mathematics, all right? They're true for any textbook. And the second rule is you never want to leave a radical appearing in the denominator of a fraction. This is not considered to be simplified. So there's three bases that you need to, check out before you call your result, your final answer. Just make sure that none of these are being violated. All right, so with that, let's see if we can just dive right into a big old cubed root. How about the cubed root of 40 times a times b to the 13th times c to the 17th power? We want to try to simplify this cubed root. Why can't I just call this my answer and just say this is it? Why do we need to do anything here? Which one of these criteria are being violated? Anybody? Which one do you think? This is violating which one do you think? Well, let me ask you this. Do you
The
think
first one.
Yeah, it is. The first one's being violated big time. We got a lot of perfect cubes underneath here, don't we? I know it doesn't look like it, but there's a lot of perfect cubes being harbored by this monomial here. So we need to uncover all these perfect cubes. Now, ladies and gentlemen, 40 is not a perfect cube of a whole number. Don't get me wrong. However, do you agree that 40 does factor down? And there's many ways to factor 40. You could factor 40 as 2 times 20. You could factor 40 as 4 times 10. But what would be the optimal way of factoring 40 to uncover a big old perfect cube? How about 5 times 8? Do you agree? Because 8 is a big perfect cube of 2. Isn't that true? That would be the optimal way of writing 40 in factored form to uncover the largest possible cube that it's harboring. Now, a to the first power does not have enough factors of a to call an a cubed, so we just leave it as a to the first. But b to the 13th power, I believe, has several perfect cubes of b in it. Precisely how many? Let's find out. Take 3 and divide it into 13. How many times 3 divided into 13? 4 times with 1 left over. Do you agree? So b to the 13th power can be rewritten as, watch this, b to the 4th power cubed times a lone factor of b left over. Everybody see this here? B to the 13th is written as b to the 4th power cubed with 1 factor of b left over. And b to the c to the 17th, how many perfect cubes of c are in c to the 17th? Divide 3 into 17 to find out. 3 goes into 17 5 whole times with 2 left over. So c to the 17th can be rewritten as c to the 5th cubed, c to the 5th cubed with 2 factors of c left over. Agree? And now, ladies and gentlemen, I could bust this up using my product rule. I can break this up like this, where I'll have all my perfect cubes underneath my cubed root, kind of like separate here. And then I got some things underneath my cubed root that must remain. For instance, the 5 must remain, the a must remain, and the b and the c squared must remain. Okay, now, so we have the cubed root of a, b, c squared, which this must stay underneath the cubed root, and this has to stay underneath the cubed root. So I'm going to put these back together again. So therefore, I'm going to have the cubed root of 5abc squared. And all this is going to come out. Do you agree? Because what's the cubed root of 8? That brings this out as a what? 2? What's the cubed root of b to the 4th cubed? What's the cubed root of this b to the 4th cubed?
B to the 4.
B to the 4th. That's it. comes out as b to the fourth. These are gone. They came out from underneath the cubed root. And what's the cubed root of c to the fifth cubed?
C to the-
Just c to the fifth. You are correct. And there you go. That'd be our final simplified answer. We simplified that cubed root. It's called simplified because we no longer have any perfect cubes underneath this cubed root. So your answer is 2b to the fourth, c to the fifth times the cubed root of 5abc squared. All right. So this one problem shows us how underneath cubed roots we're hunting for what? We're searching for perfect cubes. Underneath square roots, we're searching for perfect what? Squares. Underneath fourth roots, we're searching for things to the what? Underneath fourth roots, we're searching for things to the fourth power. Underneath fifth roots, we're searching for things to the fifth power, etc., etc., etc. Correct? So in general, you never leave anything to the nth power underneath an nth root. We're not going to consider to be simplified there. All right. So does any of that make sense there? How we simplified that cubed root? We had to extract all the perfect cubes out from underneath it. Okay, and that would also be true for a square root. Okay, now let's see here. Ladies and gentlemen, do you remember how to add and subtract radicals? Add and subtract radicals. In order to add or subtract radicals, they have to be like radicals. Much in the same sense as we talked about like terms in the past. Okay. In other words, like terms are like 2x and 3x. These are called like terms because they both have the same variable part. And these would combine to give us 5x as we add their coefficients together and keep the variable part the same. Works essentially the same way with like radicals. To be like radicals, the indices of the radicals have to be the same, and the quantity underneath them has to be also identical. So these are called like radicals because they're both nth roots of b. So if I have like a times the nth root of b plus like c times the nth root of b, we can combine these like radicals and call our sum a plus c of these nth roots of b. Everybody see that there? We combine like radicals. And that's also true if you subtract like radicals. If I got a times the nth root of b minus c times the nth root of b, these would combine to give us a minus c times the nth root of b. The key is they have to be like radicals. The radicals have to be identical, both in index and also in radicand, the quantity underneath them. Okay. All right, so let's take a look at this problem here. If I got 2/5 times the square root of 75 minus 2/3 times the square root of 27 minus 1/2 times the square root of 12, and I'm being asked to simplify this expression. So the instructions say simplify. Well, if we look at this expression as is, initially it looks like there's not anything we can do with it because it doesn't look like any of these radicals are like radicals. Oh, don't get me wrong, they're all square roots, but they got different numbers underneath them. Here we have a 75, we have a 27, and a 12. They do not appear to be like radicals as is. But ladies and gentlemen, that's not to say that they're not like radicals, because they may be like radicals, and the only way to discover if they're like radicals is to try to simplify them first. In other words, underneath this first square root, is there any perfect square that's being harbored in 75? What would be the optimal way of factoring, writing 75 in factored form to uncover any perfect squares? And your calculator can help you out here. You can start dividing 75 by various numbers. And after a little thought,
Do you like 25 times 3?
Yeah, 25 times 3 would be the optimal way of writing 75 in factored form, because 25 is a big old perfect square of 5. Do you agree? And we're searching for perfect squares. All right, in a similar sense, 27 is not a perfect square of a whole number. However, I think it's harboring a perfect square. What would be the optimal way to factor 27 to reveal all the perfect squares that are in it?
9 times 3?
Yeah, 9 times 3 would be the way to go, because 9 is a big old perfect square of 3, correct? There's a perfect square. All right, how about 12? 12 is not a perfect square of a whole number. However, it can factor into what? To reveal perfect squares.
4 and 3.
Yeah, I mean, you could have went 2 times 6, but ladies and gentlemen, either 2 or 6 are perfect squares. Not a good choice for the factored form of 12. How about 4 times 3 or 3 times 4? That's a better choice because 4 is a big perfect square of 2. Okay. All right, so now let's further simplify these. The square root of 25 would bring the 25 out as a what? As a 5. And that 5, which is a square root of 25, is going to come out here and get multiplied by the 2/5. The 25 is gone. It came out as a 5, but the 3 must remain underneath the square root. Minus 2/3 times, what's going to come out and join the 2/3 as a factor? What's the square root of 9? That comes out as a 3, correct? And that will multiply by the 2/3. The 9 is no longer underneath the square root. We took its square root, but the 3 has to remain underneath the square root. Coming to join the 1/2 out here will be the square root of 4, which is what? 2. It's gone underneath the square root and the 3 remains. So you know what? After simplifying these square roots, we can certainly see that every one of these are like radicals. They're all square roots of 3. So we have to go further. Now, 2/5 times 5 over 1 is 10 over 5, or you could cross cancel the 5s out and call this 2. So we have 2 times the square root of 3 minus, look at these 3's cross reduce out, leaves us with 2 times root 3. And these 2's cross reduce out here, or 2 over 2 reduces down to 1, however you want to think about it. And you got minus square root of 3. Heck, what we really got here is 2 square root of 3 minus 2 square root of 3 minus 1 square root of 3. What's 2 square root of 3 minus 2 square root of 3? What happens to these 2 square roots of 3? They cancel out to 0. Do you agree? My final answer is going to be negative 1 square root of 3, or we can just say negative square root of 3. Ladies and gentlemen, we are done. We have simplified that radical expression by combining like radicals. But we had to, first of all, simplify the radicals to first of all realize that we had like radicals that are in need of being combined. Do you agree? Anybody remember doing a problem like this? Simplifying the sum or difference of radicals?
Mhm.
By first of all getting them down to like radicals and then combining the like radicals. All right. Okay. All right. Hey, I just got one last classwork for you, ladies and gentlemen. We'll call this classwork number 2. You can just attach it to your classwork 1 and send it all in on 1 page or 2 pages or front and back or whatever. Just get it to me. Please proceed in your email in the subject line with Math 130 Hybrid 02. Please do put that in the subject line so I know what's what. All right, let's try to simplify this, or I want you to try to simplify this. 1/5 times the square root of 50 minus 7/3 times the square root of 18. I would like you to try to simplify that one. And number 2, I want you to simplify this radical here. The cubed root of 250, and by all means, you can use your calculator to help with the elementary number crunching. Nothing wrong with that. But let's see if we can simplify these. We'll wrap it up after this. Okay, so this is your last classwork here today. See if you can do something with those problems and we'll check your results. Here are the solutions to these problems. Initially, number 1 does not look like we have like radicals, but upon simplifying these radicals down, they both turn out to be square roots of 2, so they must be combined. And 1 square root of 2 minus 7 square root of 2 is negative 6 square root of 2. Underneath here, we're searching for perfect cubes, and your calculator would probably help you out here immensely to discover an optimal way to write 250 in factored form would be to say 125 times 2, because 125 is a perfect cube of 5. Okay, and so the cube root of 125 brings a 125 as a 5. X to the 6, y to the 6th power is harboring 2 factors of wait a minute here. This should be y to the 6th power, shouldn't it? Should be a y here. This, okay. So y to the 6th is y squared cubed. This should be a y here, ladies and gentlemen. So you bring a y squared out. There you go. Now this is a y y squared cubed, which brings the y squared out when you take the cube root of that. And then you can bring a z cubed out and the x squared, z squared remains underneath. Did anybody get any of these correct?
Yeah.
All right. All right.
I got the first one, but I just couldn't
I
figure
got
out
the
how to.
first one, not the bottom one.
Yeah, I got the first one too.
Roots are always an issue, but now, you know, let me show you quickly on your calculator. I know I got to switch off the screen for a second really quickly, but you know, your TI-84 calculator allows you to take cubed roots. I don't know if you're aware of that, but if you hit your math button and you go down, you can see your cubed root function. Heck, ladies and gentlemen, you can see your general root function. You see that? This little x you can replace with any number to, you know, qualify it as being like a fourth root, a fifth root, a sixth root, whatever. But this is your cubed root. So like if you take the cubed root of like, what is it, 125, you'll discover 120, cubed root of 125 is 5, okay? So that's why I chose to rewrite 250 as 125 times 2, because 125 is a perfect cubed of 5, all right?
How did your Z11 turn into Z2?
Z to the 11th power, I asked myself how many perfect cubed of z's are in Z to the 11th, so I divided 3 into 11. So I literally did 3 into 11, 3 divides into 11, what is it, 3 times with 2 left over, do you agree? So therefore, Z to the 11th power, I see that I have really three Z cubes in Z to the 11th. So I rewrote Z to the 11th as Z cubed with 2 Z's left over. You see that? 2 factors of Z left over. Does that make sense there?
Yeah.
And then taking the cubed root of Z cubed just brings the Z cubed out. Do you agree? Z cubed just comes out. All right.
Okay, thank you.
All righty. So, yeah, again, ladies and gentlemen, I know I sound like a broken record, but I would strongly recommend to be successful in this class is look over the examples in your textbook of the sections I cover. That's only going to enhance things because it's going to give you different looks of which I did not demonstrate in class. Okay. And you can even do extra problems at the end of each section. There's loads of practice problems, odds and evens. I'm going to give you the solutions to all those. So there's a wealth of opportunity to do a lot of extra practice to bring your mind up to where it needs to be. Okay. So keep all that in mind. If there are no other questions or concerns, you have a good day, and hopefully I'll see you next week. Please get this classwork to me by midnight tonight. Just email to me and make sure you put in the subject bar of your email, math 130 hybrid 02. Okay, please put that in the subject line so I know that it's you guys. Okay. All right, I'll stay on the line for a couple minutes in case there's any questions or concerns or anything, and have a good day.
Can you pull up the first classwork, the second example?
And quick question, the email is only supposed to be the 4 questions, right? Not everything.
Yes, that's it. Just the 4 classworks, four questions we had. This was classwork 1 and 2 right here.
Yeah, I kind of put everything together. Whoops.
Yeah, you can put it all together on one page. That's all right. You know, I mean, if you want to call, you know, just label this classwork 1 and then classwork 2. That's fine.
Appreciate
All
it.
right, yeah, try to get it to me by midnight tonight. That'll be great. Just email it my way and you'll get your credit for the day.
I was just confused on the answer for the second
Oh,
problem.
yeah, let's see. Second solution for that one there was right here. This was the solution to the second problem for classwork number 1 here. All right. So I dealt with the outermost exponent first. I brought that into each of these 3 factors here. Then I went from there. Then I multiplied like bases, -2 times 36. Y to the -3 times y to the -4 is y to the -7. Z to the 16. Then I brought that 7. Y has to come down in the denominator because it's raised to a negative exponent. Okay.
Okay, I got it. I just had something right.
All right. Mm-hmm.
I got it. Thank you.
All right, yeah, have a good one.
Can you hear me?
Yes.
I didn't get to say here because I was trying to
Oh.
connect my computer and stuff, but I am here.
Okay, yeah, that is Carter. Okay, I got you. Thanks for telling me that.
Yep. You have a good one.
You too.